Okay, so this section is 12.4, and we are looking at the normal distribution. So recall some of the things that we did in the past. If we have a list of numbers, right? With this list of numbers, right? Remember, this just consists of data values. All right. What we can do with that is we can make a frequency polygon, or let's just say a frequency distribution table. All right, that's where on one side we have X, we have our frequencies, and we just list them all out, right? From there, what we can do is make a histogram. Right, and if you recall, our histogram could look something like this. All right, so let's say that we have, all right, let's say that we are looking at, let's say a researcher selects a random sample of 100 adult men. He measures their height and constructs a histogram. All right. So maybe it could look something like this. Where this refers to the height, and this is the number of men. All right. So what were to happen if he increased the sample, right, or measured more men? Here, as you can see, we have 1, 2, 3, 4, 5, 6, 7 different heights. All right. But if our sample size increased, what would happen with the heights? So let's think about it. We measure 100 people, and we get only these specific heights: 1, 2, 3, 4, 5, 6, 7. Measure 100 people, get 7 heights. But what if we measured more people? If we measured more people, what we should see is more heights. And if we see more heights, that means more bars. And what would happen if this person continued, if this researcher continued to increase the sample size? So if this person continued to increase the sample size, we should see even more bars. What we start noticing specifically here is that this histogram looks to be symmetric. All right, and symmetric is really where if you draw a line, an imaginary line, in the middle of this histogram, the left and right side look identical or almost identical. When we see a histogram look symmetric, we call that a normal distribution. All right, so a symmetric histogram is called a normal distribution, which is the title of this section, right? Normal distribution. So that's what we see here. What we see is when we are doing a research and we have a histogram with a lot of bars and the left side looks identical to the right side, we can call that a normal distribution. And this normal distribution is really nice, right? Because what we can do with this normal distribution histogram is turn it into a curve instead, right? Which looks something like this. We say this is the height and this is still the number of men. So I want you to understand that this here, right, this bell curve, right, is a normal distribution. And a normal distribution is just really a histogram. And remember that a histogram just comes from a whole bunch of data. All right, so that's very important to understand. This center line, right, this center line is really where you find your measures of central tendency. So your mean, median, mode, mid-range. Right? And as we start going away from our mean, median, mode, mid-range, we really call it the mean, we start calling these out here standard deviations away from the mean. So we're really putting all of these sections, 12.1, 12.2, and 12.3, together in this 12.4 section. So we are going to look at the 68, 95, 99.7 rule. what this tells us is that if we have a normal distribution, tells us, number one, 68% of the data falls within one standard deviation of the mean in both directions. 95%, 95% of the data falls within two standard deviations of the mean, and three, that about 99.7% of the data falls within three standard deviations of the mean. All right, so let's take a look at this normal distribution curve, right? So our mean is in the center. All right, this is 0. And as you can see, it says either 1, 2, 3 standard deviations from the mean. So once again, this is our center or our mean. We're going to go 1, 2, 3 standard deviations to the right, and then a -1, a -2, and a -3 standard deviations to the left of our mean. It says that 68% is one standard deviation from the mean in both directions. 68% is one standard deviation from the mean. All right, that's 68%. So here's our mean. So this and that, all of this is 68% of your data. Well, how do we find what each one are? We just do 68 divided by 2. So this is a 34%, and that's a 34%. Right, so once again, that is our 68%. The next one tells us 95 is 2 standard deviations from the mean. So now all of this is 95%. But we already have 68% in there, so we have to subtract 95 minus 68. And then to find each one of these, then we divide that by 2. So that gives us each one to be 13.5. All right, and now we see that this all here is our 95%. And then our last one tells us 99.7% is 3 standard deviations away from the mean. So now we look, we're saying all of this here is 99.7%. But we already have 95 of it taken into consideration. So we subtract that, divide by 2. We find each one of these is 2.35%. But we still have this on the outside, right? And remember that this is a histogram, so this should be 100% of our data. So in order to find that, all we have to do is 100 minus 99.7, and then we divide that by 2. So that means each one of these is 0.15%. So this is what the 68, 95, 99.7 rule tells us. And here in the next video, we'll start applying examples to this 68, 95, 99.7 rule.